So we're going to be talking about this planet right here. Does anybody know what this planet is? What's this planet right here? This guy. What's this planet? Yeah, that's Mars. That's Mars. And Mars is very famous for its color. It's sometimes called the red planet. You can't really see it very well on this part right here, but if you look at the picture further over with the rover on it, you can see that red color. Does anybody know why it's red? Does anybody know what is in the soil and in the rocks that makes this this planet red? Yeah, it's iron, and a couple of you guys are saying this. Iron is normally black, but if it gets a little bit of moisture mixed in with it, what happens to iron? What happens to iron when it gets a little bit wet? And what color does it turn when that happens? Yeah. So this is essentially rusty iron mixed in with the dirt here, okay? So there's a lot of iron content in the crust of Mars, and it has turned to rust, so it's technically called iron oxide. That's just the technical term for rust. So keep that in mind. Now, have you ever seen any dirt or rocks on Earth that look kind of like this? Do we have any of this kind of stuff here on Earth? Yeah. Yeah, we definitely do. This kind of stuff is actually all over the place. It doesn't. I see somebody saying that it's sometimes near volcanoes. Not necessarily, but that's okay. This stuff's all over the place. Most of the time, we don't notice how red the dirt is in some places because it's typically covered up with plants and other stuff here. But for example, if you go up into Georgia, a lot of the dirt and rocks are this color. It's sometimes called Georgia clay. And then there's all kinds of places like out west and all over the world so this is not unusual terrain here. Mars is basically covered with it. We aren't 100% covered with it, but it's not that strange that Mars is red. We have plenty of red patches. Oh, now, here's my next question. Does Mars right here, when we're looking at it, does it appear to have more or less craters than Mercury? Does Mars have more or less craters than Mercury? Yes, less. Definitely less. And so if it has less craters than Mercury, what did it probably use to get rid of some of its craters? What did Mars use to get rid of some of its craters? Volcanoes. That's correct. Geological activity, in this case, probably mostly volcanoes. However, it has a decent bit more craters per area than Venus or Earth do. And so that tells us that it's not it was not as active as Earth and Venus. And why would we expect it to be less active, or at least for its activity to turn off faster than the activity on Earth and Venus? Why would Mars's activity turn off faster than Earth and Venus? That's correct. Okay. So if you guys remember, I showed you this picture of the sizes of the planets. And here we go. There it is. And Earth and Venus are still active. They're still pretty hot in size because they're very large. They haven't lost that much of their internal heat yet. Mercury is we said, has lost most of its internal heat. It's never really had a chance to have volcanoes. Mars, you can see, is in between in size. So Mars was able to have volcanoes for a while, and that erased some of its craters. But now, as far as we can tell, all of the volcanoes have gone dead. Okay? But unlike Mercury, which has been completely dead for billions of years, Mars has probably only been dead for, or at least its volcanoes have only been dead for a few 10, maybe 20 to 200 million years ago, okay, is when its volcanoes seem to have last erupted. So as far as we can tell, it's probably a mostly dead planet. That said, it still has occasional Mars quakes. And Mars quakes are essentially like earthquakes, but they're happening on Mars. And we are not entirely sure why it still has those. Because earthquakes on Earth come from plate tectonics. And does Mars have plate tectonics? That's correct. As far as we understand it, Mars does not have plate tectonics. So why does Mars have Mars quakes? We're working on it, but it's still not really well understood. So let's just call Mars a mostly dead planet. Seems like its volcanoes are all dead, but it does have some Mars quakes. Okay? All right. Oh, somebody asked if it could have flake tectonics, and it does not appear to have that. So as far as we know, most of that asthenosphere layer underneath the crust should be at least mostly solidified at this point, to the point where volcanoes can't stay active anymore. Okay, now, let me show you guys a close-up of... let me show you a map of the entire surface of Mars. So if we go right here, here we go. And in this picture, you should be able to see the craters a lot better. You can see craters pretty much all over the place. There's craters, 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 craters. But Mars has a little bit of a weird divide going on when we look at these craters. What do you notice about the amount of craters in the south? Is that a pretty good bit of craters or only a few? Is this a pretty good bit of craters down here in the south? Or only a few? So a lot or a little down here in the south. Yeah, it's a lot. It's a lot. So the southern part of Mars, the southern hemisphere of Mars, has a lot of craters. And what do you notice about the amount of craters up here in the northern hemisphere compared to the southern hemisphere? What's the amount of craters like in the northern hemisphere? Yeah, it's not as many. It's much smoother up there in the north. And that's not actually the only difference between the north and the south. So the south has a lot of craters and the north has only a few. But what you can't see in this picture is that the elevation is also different. Okay, so the southern hemisphere is all at a higher elevation than the northern hemisphere. So the crust is probably thicker in the south than it is in the north. So all of the southern hemisphere is at a high elevation, and all of the north is at a low elevation. So that's why we call these two regions the northern lowlands, which are very smooth. And down here we have the southern highlands, which are very covered in craters. So northern lowlands up here, these are smooth. This is the northern lowlands. And then down here we have the southern highlands, which are very covered in craters. Looks like I got a question coming up. Let's see what that is. Is there a reason that the northern cap looks like it has more? Has more what? Oh, we'll get to that in a second. Hold that thought. Hold that thought. Okay. He was asking about the ice up there. We'll talk about that in a little bit. Let me finish this crater business first. Okay. Well, we'll loop right back around. Okay. Now, so northern lowlands smooth, southern highlands rough. Okay. So other than that, though, even though there is a elevation difference between the south and the north, overall, Mars is a lot flatter than the Earth is. Now, why is that? What does Earth have that makes it overall a lumpier planet than Mars here? Yeah. So there's no mountain ranges on Mars, no like overall mountain ranges like the Rocky Mountains, because there is no plate tectonics on Mars. And I did see that question there about possible oceans. I will get to that in a second. Okay, so here we go. Here we go. So here's the next follow-up question. Okay, if the north is smoother than the south, there must be a reason for that. And that is, in one of these regions, the volcanoes kept going for a longer period of time. Now, can you figure out which region the volcanoes kept going for a longer period of time? Was it the northern lowlands or the southern highlands? Which one had volcanoes going for a longer period of time? You could just say north or south. Yeah, that's correct. The north. And there's a pretty simple possible explanation for why the volcanoes kept going in the north for longer. Remember, I said that the crust was thinner in the north and a little bit thicker in the south. That's why the south is a little bit higher. So the reason that the volcanoes could go longer in the north is that as the planet cooled off, it got harder and harder for lava to rise through the crust. And where the crust was thicker, it stopped being able to go through it. Where it was thinner, it could continue to go through the crust and make volcanoes and have volcanoes erupt for a longer period of time. Does that make sense? So in the north, because the volcanoes could go for a longer period, because the crust was thinner, the volcanoes could erupt for a longer period of time as the planet cooled off. Okay.